multiplication division. How about addition subtraction? Addition subtraction, the rule says you go with the least precise number. The number with the least number of decimal places. So 391 minus 12.6 plus 156.1456. Now, simply by looking these numbers there, assuming these are the measured quantity, this one has no decimal place. This one has 1 decimal place. This one has 4 decimal places. Meaning this is probably the most precise measurement because you go to the 4th decimal place. This one is the least precise measurement. Now, when you add things together, things cannot get more precise than the least precise number that you got from your measurement there. So in this case, we need to go, when you do addition and subtraction there, you have to determine where you're going to round off. Now, you're going to round off here. The final answer should have no decimal place there. Okay. So in this case, when you do addition and subtraction there, you have to pay attention to the number of decimal places, not the number of sig figs, but the number of decimal places in the measured quantity. So in this particular example, if you add everything up, this is the answer you're going to cut. This is the answer you're going to get from the calculator. So 534.5456. According to the rules of rounding there, this is the digit I'm going to keep. The number immediately to the right of that digit is 5 or more. So we round it up. The answer is going to be 535. Okay, so that's how you do the rounding. That's how you do determine the number of sig figs you're going to keep. And when you're trying to determine where to cut off, you have to make sure you follow the rules of the rounding there. Okay, again, using that grading policy there, 89.4, cut off the 4 there, you stay at 89, 89.5, round it up to 90. Okay, so that's what we do. That's what we talk about in class there, and we'll make sure that we are consistent with the policy. The policy is consistent with what we're teaching here. Okay, so the rounding involves a significant figure, and the calculation involving significant figure. Now, these are the two separate examples. One multiplication division, the other addition subtraction. You know that when you do calculations, and there will be more complex calculations involved in there. Sometimes you're doing addition, subtraction, and multiplication division all at the same time. So when we're trying to determine the sig figs there, we use the term of precision and accuracy there. And sig fig reflects the accuracy of the measuring equipment there. So what's the difference between those two terms? Accuracy versus precision. Now, they are not the same thing. First of all, we have to make sure that we understand. Accuracy refers to how close the measured value is to the actual value. Okay, so if we have a standard, say a piece of wood, we know the standard value is 10 centimeter. You do measurement though with an equipment, a ruler, a vernier caliper, you may end up with the numbers slightly less or more than 10 centimeter. So we know the true value is 10 centimeter. Your measured quantity could be a little bit more less, it could be a little bit more. Okay, so how accurate is your measurement? Well, it depends on how close you are to that 10 centimeter as the true value is. Precision, however, refers to how close a series of measurements. You can do repeated measurement. Now, if you have something wrong with the measuring equipment, the true value will be 10. You may end up with 8.5, 8.6, 8.45, for example. Those are fairly closely clustered numbers and measurements there. But it's far from the accurate number, the true value there. So precision, you can have a fairly precise measurement, but not necessarily accurate. Okay, so pay attention to these terms, because in the laboratory, you will be asked to determine whether a particular measurement is accurate or precise, or sometimes both. What we want in a laboratory, though, for any measurement, we want it to be precise and accurate. Okay. An example here, if we ask you to measure the mass of a sample there, okay, we know the true value for the mass is 10.00 grams. And you do multiple measurements there. 3 students did the measurement there. And these are the numbers we got from the measurement. Which one is accurate which one is precise, which one is both accurate and precise? Well, just by looking at the number, you may not be, it's not very visual, so let's just plot it, okay? The blue line represents the true value. Student A, you look at the measurement, some higher than the true value, some are lower than the true value. So this particular measurement is something that we do not want in the laboratory there. It's neither precise nor accurate. The thing is, the average is fairly close to what is supposed to be 10.13, about 10% more, 13% more. Okay. So this is the measurement in the laboratory there. This one, the average is 9.79 grams. Okay. You can see the measurement, the four measurements that the student took are fairly closely clustered together, but it's far from the true value. So this is precise, not accurate. This is what we want when we do measurement in the laboratory. All of the four measurements are fairly close to what the true value is supposed to be, and they average out to be 10.01. That's the closest to the actual value, to the true value here. So this is something that we want when we do measurement in the laboratory. We want something to be both accurate and precise. Pay attention to these two terms there. You will see questions on the final exam related to precision and accuracy. That's a warning there. I'll see how many people will remember this. Okay. So talking about the precision and accuracy there, and this is actually what's in your textbook there. So the result of student C displays little systematic error or random error. We use the term systematic error, random error. Random error is that when you are using an equipment, doing the measurement there, you do the measurement this time with one person, another person use the same equipment, do another, you end up with different readings there. So different readings come from different person who uses the equipment here. So that's a random error. A systematic error, however, is that you may have some issue with the calculation of the instrument. Yesterday when you were in the lab, and I took you to the balance room there, so we asked you to use the same balance for mass measurement. One of the reasons there is because each balance can be off by a little bit. There's a systematic error built in. No matter how hard you try, you will never get a precise measurement. You will never get 100% accurate measurement on the measuring equipment there. So there's always a systematic error. If you measure your masses during the same lab period, if you're measuring the mass of your samples on different balances there, you are adding all of the systematic error into your measurement. Your measurement is less accurate, less precise. Yeah. We want you to use the same measuring equipment with the same systematic error. At least that will minimize the systematic error that in your measurement there. So that's something that we do want you to pay attention to. And this is really something taken away from the lecture part there, and we're talking about the laboratory measurement there, and measurement that we do in the laboratory there. And these are the things that are also important. Lecture and lab, I mean, physical science, has something to do with the actual measurement there. So you have to pay attention to both laboratory activity and the lecture topic that we covered there. Okay, so we always try to, whenever I can, I always try to bring the laboratory activity into the lecture there. So this is something that we, another definition, how we define random error, how do we define systematic error. Okay. So pay attention to these terms there. Now, here's a practice problem. We ask you to calculate the density of this piece of metal block, giving you the measure